Hey, good afternoon, everyone. Good afternoon.
Hello, Professor. How are you?
Good. How are you,
Good
Claudia?
afternoon.
Good
Doing well,
afternoon,
thank you.
dear. How are you? All right. So we have 11 people in the collaborate session. Let me quickly check how many people are in the forum. I have 11, so exactly matching number. Um, okay. Hopefully, the rest of the class will catch up shortly. Um, so in our last class, we actually did everything about the single cash flow model. Um, so we're moving on to multiple cash flow model today. Multiple cash flow model. Now, um, uh, okay, so single cash flow model is basically what we did, right, until last class. Basically, finding um, future value from principal and 1 plus r raised to n, right? Right, and we have other formulas that are derived from this base formula, right? Like finding present value, right, and finding r, finding n, right? I'm not going to write all of them because they are all derived from this base formula, and but they are all called single cash flow model. Single cash flow. Why? Because there is only one single cash outflow and single cash inflow. What does that mean? Now think about it. Um, this is all based on the model where you put like certain principal in the bank today, something like 10K, uh, which is a single deposit, a single payment or deposit, right? A single principal, um, and you just forget about it. I mean, you sit there, do nothing, and the rest uh, for the next 5 years, the bank will take care of it, right? The interest rate will take care of it, in other words. So, and at the end of year 5, then you get something like, let's say 16K. Uh, um, so that's a single cash inflow, isn't it right? There was single cash outflow 5 years ago, and now single cash inflow, right? That's why it's called a single cash flow, right? But this is not the only pattern of uh, cash flow. For example, there can be uh, if you borrow money. Suppose you borrowed 1 million dollars. Suppose you borrowed $1 million at 10% interest rate for 10 years. Then um, then the reality is, is it gonna work exactly like this? Is it gonna be like, oh, I borrowed, $1 million. So 10 years later, uh, will I pay back like, $1.6 million 10 years later? Hmm? Can you ever imagine a situation like that? Hmm? I mean, if you borrow $1 million from the bank, how do you pay back? I mean, does the bank wait 10 years? Hmm? I mean, This is not a rhetorical question. I'm asking you.
Oh,
If you borrowed, huh?
interest.
Of course, there will be interest, but um, does the bank wait 10 years?
No, they collect the
No,
increments usually.
Exactly. They don't wait 10 years for you to come up with, the entire future value. No lender waits 10 years, right? Waiting for you to come up with, principal plus interest in 10 years. In reality, what happens is that they start collecting the payment from the next month. In other words, you pay back not in a single cash flow, right? In a single lump sum. You start making the payment in installment, in monthly installment, right? So if it is for 10 years, then you make 120 monthly payments, right? So that's the reality. And if that's the case, think about it. That's not a single cash flow. That is actually, there was a single cash inflow because you borrowed 1 million, right? But then when you pay back, there will be multiple cash outflows, right? 120 monthly payments to be exact. So in reality, there are multiple cash flow models. Of course, when you borrow money, that's the way it is being paid back. But if you buy a stock and leave it for 5 years, if you buy a stock and leave it for 5 years, and on average, if the annual return on this stock is like 10%, then uh, it's gonna work like this. It's gonna work exactly like this. But if you borrowed money uh, and you're the borrower. And from the lender's perspective, of course, then there will be, from the lender's perspective, there is a single lump sum cash outflow at time zero. And from the next month, there will be uh, monthly cash inflows for the next 120 months, right? So that's multiple cash flow model. So as an example, let me take you to, okay, let's take a look at this example. Suppose you are planning to go to graduate school in 5 years. Suppose you want to go to graduate school in 5 years. So, and the graduate, how much does it cost? Let's say you want to apply for an MBA program, right? You want to get an MBA, so you apply for an MBA. You're looking for you're researching MBA programs, um, and most Ivy League schools, it would be more expensive, but at least it would cost in most Ivy League schools it would cost 40K to 50K a year, right? And uh, if you um, if you do well, you can finish in 2 years. Um, Even most state universities, it would cost about 40K a year. Um, CUNY, I don't know. My guess is CUNY it would cost about 30K a year. So for 2 years, it's gonna cost 60K, right? Now, then next question is, how are you going to fund it? In other words, how are you going to prepare this 60K? So obviously the best thing is if you have a part-time job and if you can save at least something like $800 or $1,000 a month, right? You will then suppose let's say you can save $800 every month, um, and it has to be a constant amount. I mean, it shouldn't be erratic. Okay, it should be uh, a constant amount at constant interval. So you shouldn't skip. right? Every month is so every month you have to make this payment or deposit, and you must you can't skip. It should be every month, and the amount should be regular, no erratic amount, right? It must be $800 every month. So the point is, then the idea is, there will be then, think about it. Um, there will be a long timeline. Timeline will be like, yeah. Let me. um, okay, you start here, time zero, right? I'll put it here, time zero. First month, end of first month, second month, third month, and you keep going. Of course, the end is, or the maturity is month 60, right? Because, it's 5 years. And then there's, 59, 58, right? And think about it. Um, you get paid to fund this plan, right? To fund this plan, you start working, and at the end of the first month, you can make the deposit. You make $800 deposit here. And if the APR is 6%, we know R will be 0.5%, right? Because it's 6% a year, so monthly is going to be 0.5%, right? Because our compounding frequency is, 12. And of course, that's why N is 60, right? Now think about it. This first $800 deposit will, by the maturity, by the end of our timeline, what's it gonna be? It's gonna earn 0.05, not 0.5, because uh, it's gonna earn 0.5% interest 59 times compounded. Isn't that right? And then the second deposit of 800, right? By the end of our timeline, what's it gonna be? It's gonna be 800 times 1.005 raised to 58. And so on. It's going to go on like, for all these 600, for all 60 deposits, you're gonna earn, your deposits will grow to a future value like this. Now, we don't have absolutely, there's no way we can do this for all these 60 payments or deposits. Because it's a tedious job to do it like this. But so let me show you a smaller example, smaller scale. This is a small scale example. In this example, you're making a $1,000 deposit at the end of each year, for 5 years, right? So there will be 5 deposits of $1,000 at the end of every year, and the interest rate is 20%. So the first deposit will be compounded 4 times, because it's 1,000 times 1.2 raised to 4, because it's 4, right? it gets 4 years. For 4 years, it's going to get compounded. The second one will get compounded 3 times. Third one 2 times. Fourth one just once. And the last one, last deposit doesn't earn any interest, because think about it. The last deposit is just nominally deposit, only in name. Why? Because at the end of year 5, you just dip it and take out right away. Because at the end of year 5, you will take out all of this. And the question is, what's going to be the future value of all of these deposits? And we know, it will be the sum of all of them, right? It will be the sum of, you add them up all, and it's going to come to 7,441. Okay, so our question then, you understand it's going to work pretty much in the same way. The only thing is that, we cannot really do it like this because it's going to take forever, right? It's not undoable, but it's just too tedious to do this. So there's got to be a way to simplify this. Yes, um, but we know basically at the end we will have the future. We will have the future value of all of this. Excuse me a second. Excuse me a second. Uh, all righty. So we know what's going on here. Basically, it's all these are, this is called payment, right? Uh, the deposit is, deposit is the same thing as payment, right? Because if you borrowed money, right? Um, if you borrowed $1 million, and from the borrower's perspective, this will be, a monthly payment that you have to make. But if you are from the lender's perspective, these are deposits. So payment and deposit are the same things, right? So we don't have separate symbol for deposit. Payment is the symbol, common symbol for all of them. So basically, we are going to have 60 of these, and so that means by the end we will have um, some of all these future values running from where n runs from 0 to t minus 1. And of course, uppercase T is the terminal time, and the terminal time is 60. Terminal month is 60, month 60. That minus 1. Why? Because, of course, we don't raise it to 60. We raise it to only 59 because the deposit started from the end of the first month, right? So from here to here, it's 59, not 60. If we started from here, it's going to be 60. But normally we start from here, right? Because think about it, you get a part-time job first, and you got to get paid. Before getting paid, you don't have money to deposit. Of course, you probably have already money, uh, you know, but that will be another, case, another story. So then at the end, we will have, this is the total that we will have, and this is called future value of annuity. Okay, so now what is annuity here? Annuity is a regular payment or deposit made at regular interval. Okay, that's annuity. So annuity sounds like annual thing, something annual only. No, not only annual. It can be monthly, it can be quarterly, it can be even daily. It can be also annual. So annuity, basically to be defined as annuity, right? Um, the payment or deposit must be in regular amount and at regular interval. Okay, that's the definition of annuity. But then this is only, this is not, you might think, so this is the formula. No, this is not the formula. This is only a nice way of uh, condensing, nice way of, summing up all 59 of them, 60 of them, 60, because, we are starting, um, uh, the last deposit will be exactly where n is 0, right? If n is 0, it's 1, right? The whole thing is 1, so it's just going to be the payment. So, but when we have, this is just the conceptual representation, but this can be reduced to, this can be transformed into payment times 1 plus r raised to n minus 1 over r. Okay, so this is the reduced formula, reduced form, right, of this long, think about it. If you don't use summation sign, that's going to be like, you're going to have 60 terms of that, right? Which is going to be a very, and I'm going to, later, when we have time, I'm going to show you how this formula was derived. But this is basically, how we find the future value of annuities. So here, so let's see, let's figure out um, how we can do that. So I want you to download. This file, you already have it. You already have it. It's only a matter of, downloading it. And you have already downloaded it in the last class. So I want you to open that again. And then you open it. It will be all, all in blank, right? Should be, in blank. Everything must be, all the highlighted cells must be blank, right? Why is it not in blank? All right. So if it is all in blank, right? So do you have this file in front of you? Do you have the file in front of you?
The bond valuation?
What?
What's the name of the file? Is it the
Time value?
Oh, that's what I asked. Okay, got it.
Yeah. But look at the bottom tab. It's previously we did single cash flow model, right? But we need, we are in multiple cash flow models, so you gotta select the right bottom tab, right? So Claudia has it. What about the rest of the class? Do you have this file? Do you have this file in front of you? How come nobody's answering? Only one person is present?
Well, Professor, the file is in the, where is the file?
Yeah, I was gonna ask the same because I was looking and all I see is the other Excel file, the time value one?
It's time value, of course. You used
Okay.
this file last time, so you must have downloaded it. If not,
Okay.
it is, of course, in the topics folder. Where would it be? It's time value of money, right?
I
And
have
it
it.
says time value of money, Excel. The extension says Excel, right?
Yes, I have it.
Professor, you said
Okay.
a topics folder. I don't have a topics folder in Blackboard.
What do you mean? What do you mean you don't have topics
I
folder?
believe it's in section 3 of his announcement or the course materials.
No, no, no.
It's course
It's course
materials. The
material.
title is topics, not the folder.
Oh.
Right.
Oh.
So when you go to course materials, you'll see different topics. You're gonna go to topic 3.
Right,
Go to
right.
the one. Anytime it says XL at the end, it's usually a spreadsheet.
Oh, okay.
Look, it's more than it's more than half the semester, right? We have passed, we have passed 8th week point already. It's been more than half the semester, and you still don't know where to find the files?
Professor, you have to understand some people are not tech savvy or computer literate, so sometimes it just takes them a little longer. It's not that they can't find it. It's
Well,
just
yeah,
they
but
just need a little bit of help. That's all.
it's been 8 weeks, and every week we have used Excel file that we pulled from the topics folder,
No, I'm
right?
sorry, Professor. I just had to make sure I went to the right place.
Well, good. Yeah, well, you're in the right place. But now this should be like your second nature. I mean, it's not the first time, right? It's not the first time you are in this class, right? So it's on the course material, right? And we've been, it's very, we've been doing this repeatedly, right? Time value of money, that, we're in that topic, right? And always the first two files, these are files, and otherwise these are links. Only these are the links, right? And then file extension is already, clear. Like that's Excel file. This is the slide. This is Excel file. I provide. It's very, regular pattern. So I believe, I hope you all have this file in front of you. And I told you to look for the right bottom tab, right? So let's go to row 2, and the row 2. This is exactly our example, isn't that right? $800. That's monthly deposit. 6% APR, 5 years, and the compounding frequency is 12. First of all, then we know what to do to find the periodic rate and n, the actual number of compounding. So periodic rate is always APR divided by n, right? So it's 0.5%. Actual number of compounding is 5 years times 12 months. So it's 60. Now then we use our formula here. We use our formula, right? The formula I put there as well. So basically, it's going to be payment times open parenthesis, open one, 1 plus r raised to n minus 1, close parenthesis, divided by r, right? Okay. All right. Everyone is good to that point, and hit enter. Okay. Then you got that, right? But then this is not the final answer. Okay. First, um, uh, algebraically, we use bracket, but the bracket is the when we put it in Excel, there's no difference. I mean, there's no bracket, in Excel when we use Excel. It's just another parenthesis, right? So that's what it is. And when you get there, you're only you only answered only the you only cleared the first hurdle. Why? What is the ultimate question? Ultimate question is, if we make $800 deposits every month for the next 5 years or 60 months, are we going to be able to meet our goal? Isn't that right? The question is, are we going to be able to meet our goal? Isn't that right? And what is our goal? What's our goal? Anyone? What's our goal? You forgot already. Huh? Why are we putting $800 into this account every month? Anyone? Why are we putting $800 every month? So you have already forgotten what was our problem. It's because we want to, because you are planning to go to graduate school in 5 years, right? And it's going to cost you $60K. So you are making these deposits every month for the next 5 years to accumulate $60K, right? But then, is there any guarantee that putting $800 every month into the bank at 6% APR, is there any guarantee that's going to reach $60K? No, we don't know. We'll have to find out. That's why we did this. So this is only half the answer, not the final answer. And it's clear that it doesn't reach our goal. $800, by putting $800, it's not going to hit our target future value, because we have the target future value. Target future value is $60K. But this scenario will fall short of our target by about $4,000, right? So just because you got the you used the formula and got the answer, it's not, you're not there yet. You can't just say, hooray, I got it. No, you haven't got it yet. You can't walk away from the problem yet. So then, what should I do? Oh, well, there can be three alternate strategies. One, what if I increase my monthly deposit? Yeah, suppose you increase it by $60 every month, right? So increase the monthly deposit to $860. How's it gonna work? Or third alternative is, how about we find a bank that pays higher interest rate? So suppose we found a bank that pays 8% a year. But again, I've been telling you over and over, the banking industry is a very competitive industry. If nobody pays superior interest rate, they will owe, if average is 6%, paying 7% is even a significant difference. And so it will be almost unrealistic to find the bank that pays even 2% more on average. They will the difference will be only about, like a 0.5 at best, right? 0.5%. But anyway, if you are able to find a bank that pays, a higher interest rate, that would be another, alternate strategy. And then uh, uh, another scenario is, what if you extend this timeline to 6 years? I mean, uh, do you have to go to graduate school in 5 years? How about, if saving $800 for 5 years is not enough to, hit that goal, how about 6 years? I mean, if you can just wait another year, right? Now, think about it. All those alternate strategies, alternate scenarios, you can evaluate all of them all at the same time. Why? Because, all you need to do is just select these three cells and drag it down, right? And then you can compare those alternate strategies all at the same time. So first, if you deposit 860 every month, then oh yeah, you made it. You made it. But you overshot the goal. I mean, there's no harm, but I mean, having more money, you just barely, overshot it by $2. But this, but this tells you, from this, you can tell, oh, the exact monthly deposit, exact payment, monthly payment, we can at least tell it should be something not far away from this, right? It would be something smaller than 860, but it won't be that much different. It would be probably 859 something, right? And at 8%, you're still about $1,300 short, right? With 6 years, you're more than enough. You have more than enough. You'll have, 69,000. Um, again, we can explore the alternate scenarios. You can explore alternate scenarios, but this, well, it doesn't take that much time. You can do it easily in a split second, so it's not a big deal. But if you really want to know what should be the exact payment, yes, we can find that. We can find that. But before we do that, what is column H? What is this? That's future value of annuity. And what is that subscript D? What is that about? Well, so in annuity, there are two types of annuities. So let's take a look at this. This is the simple. One is, this type of annuity is called ordinary annuity, ordinary. Yeah. And in ordinary annuity, when does the deposit or payment start? At the end of each period, right? When is the deposit made? At the end of each period. But I told you, you can start from time zero. You can make the deposit from time zero. But then that's called annuity due, right? But then think about it. This is the example of annuity due. Ignore the difference in payment amount and interest rate. Just assume that they are so 1,020%, right? But then think about it. First deposit is made at time zero, and it's going to earn interest 5 times compounded. 5 times, because it's 1, 2, 3, 4, 5. The second deposit will earn interest 4 times compounded. Third deposit, 3 times. Fourth deposit, 2 times. Even the last deposit will earn interest once. Okay? So think about it. So the difference between annuity due and ordinary annuity is that the annuity due has one more compounding. otherwise, if we take it back to this, right? Everything has just one less compounding. All of these future values have one less or one fewer compounding. So they will become the same thing. But the only difference is now that, and I told you, ignore these numbers. Also assume $1,000 and 20%, right? Interest rate. So the whole point is, when I ask what's the difference between annuity due and annuity, ordinary annuity, most of the students say, oh, one one starts at the beginning of each period and the other one at the end of each period. Yeah, that's verbal definition, right? Annuity due, think about it. Due means when you start with something due, that means that payment is already due. So the payment has to start at the beginning, not at the end of each period. And other than that verbal definition, when I ask for the definition, it's always mathematical definition. And the mathematical definition is that annuity due has one more compounding than ordinary annuity. But but ordinary annuity is the default, right? Why? Think about the word ordinary. What does ordinary mean? Ordinary means, that's the default. Okay, that's the default. So unless there is a specific instruction that this problem assumes exact annuity due, then unless there is a wording like that, specific wording like that, then it's by default, ordinary is assumed always. Okay? So now we understand what annuity due is. Then how do we find annuity due? I just told you that annuity due, there's just one more compounding than ordinary annuity. So that means we can recycle. That means we can recycle the ordinary annuity, the result of the ordinary cycle times 1 plus just one more compounding. Right? You go, and then you drag it down. There you go, right? So this one will be, it's the same 60 deposits, right? Same 60 deposits. Some people might think, annuity due has one more deposit. No, it doesn't have one more deposit. It has one more compounding, not one more deposit. Okay? Both have 60 deposits. Annuity due, ordinary annuity, they both have 60 deposits. But there's one more compounding, and one more compounding results in this difference. Okay? Alrighty, so it's about time to take a break. So let's take a 10-minute break. And if you have any questions, I'll take the questions after the break. So if you haven't completed this, I will turn it into a formula view. Okay, so you can complete it during the break. Okay. Let me resize it so you can see the whole thing. All right, I think that's it. All right, we'll go into the break. All right, we're back. We're back. Is everyone there?
Yes.
Okay, great. I hope at least two people. I can see two microphones. At least two people. So, so we now know basically how to use this formula, right? And we applied it to evaluate alternate strategies. Uh, this can be done in a single second. That's what that's the beauty of Excel. Next, so our question was $860 every month. Yeah, this will satisfy our condition, or this will meet our target future value, but uh, it's not the exact amount because it overshoots by $2. It overshoots our target by $2. So how do we find exact payment? Um, well, this can be done easily because look, we were able to in the single cash flow model, right? Um, we basically derived formula for P, right? We derived every formula from the base formula by uh, solving that equation for why am I doing this? By solving every equation for that unknown variable. So it's the same thing here. Because in future value of annuity, right? In future value of annuity, why is it like this? We have also four unknowns, four possible unknowns. Uh, the first is of course future value of annuity. But that means this is known, right? And this is known, and this is known. They are all known quantities. Uh, Also, there can be then the question can be what's going to be the payment, right? In other words, when payment is the unknown, that means the other variables are known. What about R, right? And what about N, right? So all these, the same formula can be solved for four different unknown variables. So now let's think about solving it for payment, right? So if we, from this formula, right, which is the base formula, right? If payment is the unknown, right? If this is the unknown, what should we do? Remember, it's always the same. I've been telling you over and over that no matter how complex the equation may look, right? As long as we can identify z equals x times y format, right? As long as we can identify that format, then we can solve for anything, right? If x is the unknown, we know what to do, z divided by y. If y is the unknown, z divided by x. Isn't that right? And as you look at this formula, this is already presenting itself, right? It's already in that structure, right? Isn't it right? It's already in that structure. This is future value of annuity. This is exactly that is exactly Z. That's Z. Payment X. And the thing in the bracket, right? That's Y. Isn't that right? That's Y. So then solving for payment, it's going to be simply, then Z divided by Y. So payment will be FVA divided by the thing in the bracket, right? And when you divide by something, it's the same thing as multiplying by the reciprocal, isn't it right? So if I multiply FVA by the reciprocal, and raising something to negative power, that's reciprocal, isn't it right? Everyone understands that, right?
Yes.
Yeah, good. Now I'm talking to some people. Now I'm getting some response. So if we multiply the reciprocal of that thing in the bracket, then which is then we'll get the payment. So so if I rewrite this, the payment will be FVA times, what's the thing in the bracket? This is made a little too. R over 1 plus R raised to n minus 1, right? That's the reciprocal of what was in the bracket, right? So we found it. We found that formula. So then let's nail the exact payment, okay? Let's nail it. So the formula, I put it also here, right? But before we do that, we need to fill in this. Of course, it's going to be the same, right? This divided by 12, 0.5%. This times 12, right? Okay. That once that is filled in, let's do this. FVA times R. You might wonder, what about the bracket? No, don't worry about when you multiply something to a fraction. Anyway, it will be multiplied to the numerator, so it gets multiplied to the numerator, and we have only R in the numerator, so we don't need any bracket there. And then in the numerator, open the outer parenthesis and open inner parenthesis, and 1 plus R raised to n minus 1. Okay? And close the parenthesis, and that's it. We're done. If you hit enter, 859.97. That's exactly. Remember when we did this, right? 860, when we explored this scenario, it overshot our target just by $2. So I told you it can't be far from this. It can't be far from this. It will be smaller than this, but it can't be that far. Yeah, only 3 cents short of 860, and then 5 years later you hit the goal. Okay. So let's try another one. Row 11 is 60K, same target future value, but the APR is 7.5, 6 years, and quarterly compounding. So what do? First, we'll need to have this filled in, right? Okay, so, quarterly rate is 1.88 at 24 quarters. Now we're ready to do that. I can copy this and paste it there, but, just to practice our formula, right? FVA times R divided by, open parenthesis, open another one, 1 plus R raised to n minus 1, close parenthesis. Okay, and hit enter. That should be, right? All right. Now, so everyone got this right? Everyone got this right? Let me just show the formula view there. Any questions so far? Any questions? Everyone got this right? I don't hear you. Everyone got this right? Go ahead. Go ahead. Who was that?
Oh, that was Tia. I said I got.
Any questions? I hope everyone got it right. Kelly, you have a question?
No,
Kelly?
no questions. It's fine.
Okay. Is Mukhtar here? Mukhtar?
Yeah, I'm here.
No. Any questions?
No.
Okay. All right. Then let's think about how to solve for R and how to solve for N. Now, unfortunately, for rate, for R, right, there is no single unique formula for finding R in annuities. Okay? And in the only way to do this in the past, before the age of computing, the only way we could do this was by trial and error method. In other words, by plugging in a possible candidates, right? Plugging in the numbers that can be possible candidates. And so it was basically a guesswork. And trial and error is not really a scientific method because you are just trying out a bunch of numbers until you get it right. But then there's no guarantee. I mean, how many trials it will take? If it takes, like 1,000 trials, obviously this is not gonna be a very good, efficient way. But how do you nail it exactly to a cent, right? How do you nail it exactly to 1/100th of a dollar? It will have to take almost, you might wonder, 859.01 through 859.99. I mean, wouldn't 100 trials suffice? No, there's no guarantee that it would stop only at 2 decimal places. We might need 3 decimal places to be exact. I mean, even though this is showing only, right now is showing only 2 decimals, you will see if we increase decimals, it may be not exact. See, it's not going to be that. To nail the number that exactly meets this, right? The level of precision can go much deeper, right? But we because in case of money, right, in dollars, in case of dollars, since we only use nothing below a cent, we don't have any denomination below a cent, so it would suffice to round it to the second decimal place, right? Round it to the nearest hundredth. Um, so that's why I'm saying it could take 1,000 trials, more than 1,000 trials. Oh, that's totally not scientific, and it's obviously not efficient, right? So is there but then since the age of computing, right? Now that's what the computers are good for. For humans, it will take days to uh, try out 1,000 possibilities, right? 1,000 possible numbers, but the computers can run 1,000 calculations in a split second, right? The computer can plug in, like thousands of numbers in a split second. So we will have to use, to find the rate, we'll have to use Excel's um, rate function. Okay. So before we do that, we'll have to okay, uh, we'll have to fill in this, right? We have to have n ready, and then because we are dealing with monthly compounding, the rate is monthly rate. We must first find the monthly rate and then convert it into annual, right? So we use Excel's function. This is the function icon. F of x, that means function of x, right? This function. And then normally you will have most recently used, right? The menu, the default menu is most recently used. And if you ever used, rate function, it will show there. But if you haven't, it's not going to show up there. So you go to the financial category. And since all these, variables are in alphabetical order, you scroll down until you run into R, right? Rate. So select rate and give it what it's asking for. It's asking for n periods. That's n, right? N periods. How many? Number of periods? N. Okay. And payment. Here's the payment. And there's no present value because this is future value of annuity, but we have future value. This is our target future value. You enter it and type. Type means before type guess. This is what you guess, but we don't need to use guess. We'll just if you were to guess, then no need to use Excel's function, right? So ignore guess. Type means ordinary annuity or annuity due. Ordinary annuity or annuity due. And I told you, if it is ordinary annuity, and by default, unless it was clearly instructed, unless you were clearly instructed to assume annuity due, it is ordinary annuity by default. And for ordinary, you don't enter anything or enter zero. Okay, you don't enter anything or enter zero. If it is annuity due, you enter 1. Then why do you enter 1? Why do you think it's 1? Why do you think 1 represents annuity due? Anyone?
Why we
Anyone
make
has
it?
any? Huh?
the question? What was the question?
The question is, why is it 1? Why do you think you put 1 for annuity due?
Because it's 1%, 100%.
100%?
Yeah.
No, why 100%? Does ordinary does annuity due have 100% interest rate? I mean, why do you say 100%? No, it's not 100%. It's not because anyone else? Anyone else? If you can answer this, that this is a 1-point question. Anyone? Okay, so I just explained a while ago the only difference between the annuity due and ordinary annuity is that the annuity due has one more compounding, right? One more compounding than the ordinary annuity. So by entering 1, that means, do one more compounding. That's it. But since this is, ordinary annuity, and there was no mention that you have to assume annuity due, no mention. So by default, ordinary annuity. So you leave it blank, okay, or enter 0. But then by now, so everything that needs to be entered has been entered. Then by now, we should already see something here, but nothing shows there. Why? Because there's one thing that was that needed to be done, which is entering payment as negative. You put minus sign. You need to put minus sign. Why? Why is it? What happened here? Why is it in French? This is crazy. So you have to make this minus negative. Okay. Something's not right. What was the payment is here? A. Why negative? Okay. Let me explain. Then you get it right. It's not really negative. In financial calculator setting, right? In financial calculator setting, there are 2 types of cash flows, only 2 types of cash flows, cash inflow and cash outflow. Okay, cash inflow and cash outflow. So cash outflow is always expressed as negative. Okay, so that doesn't mean it is negative, but it's money leaving your pocket, right? Think about it. How are you raising this 60K? By getting into an annuity account. And so every month you deposit, at the end of every month, you deposit this amount. That's cash outflow from you, isn't it right? Every month for 60 months, there will be cash outflows, right, of the same amount at the end of the month. There will be 60 of them. And at the end, you finally get 60K, which is cash inflow, right? Okay, it's cash inflow. So that's basically making a distinction that this is cash outflow and G8 is cash inflow. And only then the financial calculator will work. Otherwise, it's not going to work. So this way, we found, yeah, it has to be 0.5% a month. But then again, that's not the end. If the problem was asking for what the annual rate, and I've been telling you over and over, by default, all interest rates, all rates, it's a convention, right? It's basically, a convention of the finance world, right? That to express all rates as annual, right? So we need to convert this into annual, which is not a difficult thing. We simply multiply that by this, and then 6%. Okay, voila. So you have this, and then next, what if? How do we find n then? How do we find n? Right? What if the n is the unknown? What if this is the unknown? How do we find n? Again, since we are running out of time, I will skip everything and just take you to the slide page, whatever slide. This is this page of the slide. I think that's page 11. Specifically for n, this is the formula for solving for n in future value of annuity. Next one is for present value of annuity, but we're not there yet, present value of it. So this one, the formula, the result of the formula is this, of course, whatever is above it is the steps of transformation or steps of derivation, right? From the base formula, right? Going through these steps of derivation, and we have to use natural log, of course, for n, solving for n. There's no other way. It's natural log. Okay. So by applying this formula, right? Natural log of future value over payment times r plus 1 over natural log of 1 plus r. In the denominator, it's always natural log of 1 plus r. So we'll apply that here. Of course, this needs to be filled in already. Or you can do also 6% divided by m, the same thing. And then we know it should be 60. Let's see if it's going to be 60. So natural log of future value over payment times r, this is r, minus 1. Okay. You all know when you multiply by something to a fraction, it gets only multiplied to the numerator only, right? So this is perfectly all right. And then divided by, I'm sorry, that was plus 1. I'm sorry, plus 1 divided by natural log of 1 plus r. Close parentheses. And yeah, I got 60 exactly. And then converting into years, of course, you divide 60 by 12. It's going to give you 5 years. Okay. So take a look at. I'll give you like a minute to do this. So everyone got this right? Everyone got it right? Everyone got it right?
Professor, I didn't get it right, but
But so check the formula. Check the formula. Did you put in exactly this formula?
Oh, okay. Oh, you
Yeah.
said, oh, yeah, I messed up. I didn't put in the right formula.
Mm-hmm. And when you type in natural log, you don't have to you don't have to use uppercase. You just type in ln, and once you enter it, then Excel turns it into uppercase. You can all right. So if you are done with that, try out these two. Of course, you will need to have the other cells already filled in. Those, olive green highlights. Right? Or I don't know, the name of this color is probably drab, or drab, like military, color, military fatigue. All right, so for this one, we need to use rate function. So just to get used to it, let's do go to rate and give it what it's asking for. N, okay, give it N. Payment. This is the payment, and I told you to make this negative because the payment is actually cash outflow from your perspective, right? From the bank's perspective, it's cash inflow. But at the end, then the bank will have to give out 60K to you. So there will be cash outflow for them. Future value, we have the target future value, which is in where? G12. So G12. Then nothing to enter there. Type, because it's ordinary annuity. And then we'll get exactly, we see something already here, 1.88. Then you multiply this by 4, and you get 7.5. And then n, natural log of future value per payment times r plus 1, close parenthesis, divided by 1 plus r. Okay? So if you entered it correctly, hit enter. Okay? And then, oh, something's not right. Where did I go wrong? Natural log of G13 over A13 times E13 plus 1. Oh, I forgot natural log. Jesus. Natural log of E13, 1 plus E13. Hit enter. You get 24 exactly. 24 quarters. Then, if the problem asked how many years, then you'll need to convert it. I mean, it's your responsibility to answer it exactly as asked, right? And you divide it by 4, and you get 6 years exactly. Okay, so everyone got this right? Everyone? Any questions? If you have any questions, now is the time to ask. No questions. Okay. All right. So I would assume that everyone got this right. Now, here's one concern. Tomorrow the midterm begins, and midterm is all about topic 3. And if you have been doing the chapter 4, chapter 5 problems on Connect, it won't be a big deal. I mean, chapter 4, chapter 5 practice problems, chapter problems would be pretty much, the preview of what the midterm will be like. And although we haven't covered present value of annuities yet in the Collaborate session, but you understand the Collaborate session is not the main lecture, it's just the review and reflection. So by main lecture, you should have already covered all of these. Actually, as of today, these are, there's still time value of money, active and current. And I believe you're already into topic 4, bond valuation as of today, right? You must be caught up all the way to this as of today. But again, if you are, the previous, present value of annuity part 1 and 2, they are already grayed out, so you cannot, access them on the Blackboard. But I've been, my YouTube channel, and on my YouTube channel, you can watch these. So you must watch these completely and study these videos before starting the exam. Okay? And also, just to make sure, do chapter 4 and 5 problems before starting the exam. Okay? That's the best way to ensure, good score from the exam, right? Otherwise, it's going to be, you will always, you will realize it's in your best interest to do the practice problems. All right. So any other questions? And if there's no other questions, then if there are no other questions, we'll call it a day. Have a great afternoon, everyone. Yeah, if you have a question, just stick around. I will first dismiss the class and I will answer your question, okay? Have a great afternoon, everyone. Good luck with your midterm, and I will see you next Tuesday, okay? All right, stop recording.